Okay, sorry for the technical error that happened during our live session. Hopefully it will not happen again. Okay, for today's topic, I just want to focus on ionic bonding model. Okay, this table show you the position of metal and non-metal in periodic table. Okay, what important here, you must know the property of metal and non-metal in terms of atomic size, effective nuclear charge, ionization energy, and electron affinity. Okay, electron affinity is the energy is released when one electron is added to atom. Ionization energy is absorbed when one electron is lost from atom to form positive charge. Effective nuclear charge is the net positive charge experienced by the atom where electron experience attracted to nucleus, and at the same time it repel each other. Okay, why do we need to study bonds? Due to two main reasons. Okay, during chemical change there are formation of bond and also break old bond. Okay, there are three types of chemical bonding, which are ionic bonding, covalent bonding, and metallic bonding. But today we will only focus on ionic bonding. Okay, ionic bonding is the transfer of electron from metal to non-metal, while covalent bonding involves sharing of electron between non-metal and non-metal, while metallic bonding involves the electron pooling between metal and metal. Okay, so ionic bonding involves metal and non-metal. Covalent bonding involves non-metal and non-metal, while metallic bonding involves metal electron pooling between metal and metal. Okay, this figure show you the trend of bonding among period 3 and group 4, and you can see here the metallic bonding increase down the group and the covalent property increase across the period. Check the period table and relate the bonding with the trend with the position of element in the periodic table. Okay, next you must know how to write Lewis electron dot symbols. Okay, for example, here nitrogen, it is in group 5, so it has 5 valence electron. So you must locate the 5 electrons surround the element. Okay, for metal, the total dot equal to the number of electron it will lose to form positive charge, while for non-metal, the total number of the unpaired dots equal to number of electron it will gain to form an ion, or the total number of electron it will be shared to form covalent bond. Okay, octet rule state that when atom bond it gain, loss or share electron to obey the octet rule, and it work well with group 1 and group 2 metal, but it doesn't work well with transition metal. Okay, today's topic we will focus on the ionic bonding model. Okay, as you know, ionic bonding involves the transfer of electron from metal to non-metal to form ion. Okay. Metal and non-metal bonds ionic due to property of metal that have low ionization energy, and due to property of non-metal that have very exothermic electron affinity. Metal lost electron and this require energy, while non-metal the electron is added to non-metal, so energy is released. Okay, ionic compound exists in lattice structure and usually written as empirical formula. Okay, there are three ways to show electron transfer in the formation of cation and anion. First, by electron configuration. Second, by orbital diagram. And third, by Lewis electron dot symbol. Okay, by electron configuration, for example, metal, it lost one electron to form cation, and F, it will receive one electron from the metal to form an ion. Okay, this example by showing using orbital diagram. Okay, and also you can also show the electron transfer by Lewis electron dot symbol. Okay, this is example of question that require you to show the transfer of electron from metal to non-metal to form cation and anion using orbital diagram and Lewis symbol. Okay, example here, oxygen 2 minus, meaning that it will receive 2 electron from 2 sodium atom, okay, to form O2 minus, and so each sodium will lose 1 electron to form Na positive. Okay, this example how you show the loss of electron from sodium and how oxygen is received the electron from 2 atoms of sodium using orbital diagram. Okay, just a simple question for you. Why some compounds form while others don't? Okay, first, to answer this question, we must look at the total energy of the system. Okay, for any stable compound to form, we must look at the potential energy and the delta formation of the system. So, for any stable compound to form its element, the potential energy must be low and the delta formation must be negative. How to determine it? We must apply the Hess law to determine it. Okay, how to determine the total energy of the system? We can use Hess law to determine it. Okay, look at here. Remember, in order for ionic compound to form, the delta formation must be exothermic. Exothermic, the sign must be negative, meaning the energy is released. Look at here, look at one by one to understand the total energy of the system. Okay, first, look at here, sodium, solid, it requires energy to form sodium gas, and chlorine molecule, it requires 131 kilojoule to form chlorine atom, and sodium, it requires energy to form cation. Remember ionization energy meaning, and chlorine, it release energy, and then the symbol, the sign here is negative, so meaning that it release energy to form an ion. Remember the meaning of electron affinity, the energy is released when one electron is added to atom. Okay, here the term lattice energy is the energy is released when one electron lattice energy is the energy is released when ionic compound form from gaseous ion. Okay, try to calculate all the energy in each step, then you will get the delta formation for the reaction. Example here, you can see the formation of ionic compound is negative. It's very exothermic, meaning that it is possible to form ionic compound. Okay, you can use the example given for sodium chloride to understand this Born-Haber cycle for lithium fluoride. Same. Okay, as mentioned in my previous slide, what is lattice energy? Lattice energy is released when one ionic compound formed from its gaseous ion. Okay, there are two factors that affect the amount of lattice energy in the system. First, the ionic size and ionic charge. The bigger the size, decrease in lattice energy. The higher the increase in ionic charge, increase in lattice energy. Okay, you can use this example to relate size and charge with lattice energy. Okay, ionic compound hard, rigid but brittle. Okay, why ionic compound crack? This is due to when there are external force, the like charge will repel each other, and that's why the ionic compound can crack. Okay, one important property of the ionic compound is it can conduct electricity in molten and in solution, as you can see in this figure. Okay, ionic compound also have very high melting point and boiling point, as you can see in this table.